everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So, in the last session, we discussed about non-exact differential equations and integrating factor and how to find the general solution of non-exact differential equations. So, how to find the general solution of non-exact differential equations by using inspection method. So, these are the methods we discussed in the last class. So, today in this session, we are going to discuss about the method 2 of finding an integrating factor. So, it is not always possible to guess an integrating factor. So, in that cases, we are using the methods to find an integrating factor. So, and we will do one problem on finding an integrating factor using method 1. So, now see the method 2 of the finding integrating factor. So, if m dx plus n dy is equal to 0 is homogeneous differential equation and mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor. See once again I am repeating. So, if m dx plus n dy is equal to 0 is homogeneous differential equation and mx plus ny not equal to 0, then 1 by mx plus ny is an integrating factor. So, after finding the integrating factor, you have to multiply this integrating factor to the given non-exact differential equation. Then, non-exact differential equation is reduces to the exact differential equation. So, let us see what is a homogeneous differential equations. So, see the example of homogeneous differential equation. So, let us see dy by dx is equal to x square plus y square divided by 2 into xy. So, this can also be taken as function of xy by g of x comma y. So, when we are saying this differential equation is homogeneous, so that both the functions f of x comma y and g of x comma y having same degree of homogeneous function. So, what is homogeneous function? See, now we will verify whether this function f of xy is a homogeneous function or not. So, f of x comma y is nothing but x square plus y square. Now, we are verifying the homogeneous function, so that we have to replace x by kx and y by ky. So, f of kx comma ky is equal to k square x square plus k square y square. Then now this is equal to, by taking the common k square, so we are getting x square plus y square. So, what is x square plus y square? Which is nothing but f of x comma y. So, this is equal to k square into f of x comma y. Now, we can say this function f of x comma y is a homogeneous function of degree 2. Then now, what is the power of k here? 2. So, that this 2 is the degree of an homogeneous function. Now, we will verify g of x comma y is a homogeneous function or not. So, g of x comma y is equal to 2xy. So, substitute x by kx, y by ky. By substituting x by kx and y by ky, so here we are getting 2k square into xy. So, write k square first into 2xy. So, here 2xy is nothing but g of x comma y. See here, g of kx comma ky is equal to k square into g of x comma y exists. So, that this g of x comma y, that is 2xy, the function is homogeneous function, then what is the degree here? Degree is 2. See here, both the functions, that is f of x comma y and g of x comma y having same degree. So that we can say this differential equation dy by dx is a homogeneous differential equation. Right. Now, let me see one problem on non-exact differential equation by using the method 1 of finding an integrating factor. So, solve x square y dx minus of x cube plus y cube dy is equal to 0. So, observe the given differential equation first, whether the given differential equation is of the form m dx plus n dy or not. So, clearly the given differential equation of the form m dx plus n dy is equal to 0. So, what is m here? M is equal to x square y and n is equal to minus x cube minus y cube is the function of n. Now, we have to verify non-exact condition. So, what is the non-exact condition? Dou m by dou y you have to find out first. What is dou m by dou y? With respect to x differentiation partially. So, x square is a constant, derivative of y is a 1. So, now find the derivative on m with respect to y treating x as a constant. Dou m by dou y value is x square. Then now find the dou n by dou x with respect to x differentiation partially treating y as a constant. Now, the derivative of x cube is 3x square. So, before we have the minus, so put it the minus 3x square and y cube is a constant. So, constant derivative is a 0. So, dou n by dou x value is minus 3x square. So, now observe that these two partial derivative values. So, here we got the x square and here we got the minus 3x square. These two are not same. So, therefore, dou m by dou y is not equal to dou n by dou x. So, now this differential equation is non-exact differential equation. Now, we will find out the integrating factor of the given differential equation. So, let me verify whether this differential equation is a homogeneous or not. So, here what is m? M is equal to x square y and n is equal to minus of x cube plus y cube. So, you just verify if m and n are having the same degree with a homogeneous function, then we can say this differential equation is a homogeneous differential equation. So, clearly this differential equation is homogeneous differential equation with the degree is 3. The function m degree is 3 and the function the degree of n is also 3. So, that this differential equation is homogeneous differential equation. If it is an homogeneous differential equation, now we can find the integrating factor is 1 by mx plus ny. So, now we are finding 1 by mx plus ny. This is an integrating factor. 1 by, so what is m here? X square y and multiply with the x plus what is the n function? Minus x cube minus y cube into y. Now, simplify this. So, by multiplying with the x, we will get x cube y. Then in the next term, you can multiply with the y minus x cube y minus y to the power 4. So, here plus x cube y and minus x cube y was cancelled. So, remaining term we got minus 1 by y power 4. So, this minus 1 by y power 4 is an integrating factor. So, after getting this integrating factor, you have to multiply this integrating factor to the given differential equation. So what is the given differential equation? X square y dx minus of x cube plus y cube into dy is equal to 0. So now we have to multiply with an integrating factor is minus 1 by y power 4 on both sides. X square y by minus y power 4 into dx minus of x cube plus y cube by minus y power 4 into dy is equal to 0. Now, we will simplify this differential equation. Again, we are converting this equation into the form of m1 dx plus n1 dy is equal to 0. So, 1 y was cancelled here, minus x square by y cube dx. So, here the minus we will get the plus, and now we can split it as the two terms, that is x cube by y power 4 plus y cube by y power 4 into dy is equal to 0. So, in this three terms of y was cancelled. The remaining differential equation is minus x square by y cube dx plus x cube by y power 4 plus 1 by y into dy is equal to 0. So, again this differential equation is in the form of m1 dx plus n1 dy is equal to 0. Now, again we will cross check whether this differential equation is exact or not. So, what is m1 here? Minus x square by y cube and n1 is equal to x cube by y power 4 plus 1 by y. Now, we have to check the condition of exactness. What is the condition of exactness? Dou m by dou y is equal to dou n by dou x. Now, we will find the derivative on m1 with respect to y keeping x as a constant. Dou m by dou y with respect to y differentiation. So, here minus x square is a constant. Then what is the derivative of y cube? The y cube is nothing but minus 3 by y to the power 4 is the derivative of 1 by y cube. So, minus plus we will get the 3x square by y power 4 is the derivative value of m1 with respect to y differentiation. Then now we will find out the dou n by dou x with respect to x differentiation on n1. So, in this 1 by y power 4 is a constant. The derivative of x cube is 3x square. And the next we have the plus 1 by y. This is a constant term. The constant term derivative is 0. So, this is going to be 3x square by y power 4. And now, here observe that both the partial derivatives are similar, that is dou m1 by dou y is equal to dou n1 by dou x. Now, this differential equation is a exact differential equation. Now, we will find the general solution of exact differential equation. So, what's the exact differential equation here? Minus x square y cube dx plus x cube by y power 4 plus 1 by y dy is equal to 0 is the exact differential equation. So, for this differential equation, we are going to find a general solution using the concept of exactness. So, what is the general solution? Then how can we find out the general solution for exact differential equation? So, integral m1 dx plus integral n1 dy is equal to c. Integration on m1 keeping y as a constant. Integration on n1. So, you have to take the which does not contain x terms. That means, you have to take the terms free from x. So, what is the equation we got the previously? Minus x cube by y power 4 dx plus x cube by see once the previous question, minus x square by y cube dx. So, here this is x square plus x cube by y power 4 plus 1 by y dy is equal to 0. So, this is the equation, nothing but exact differential equation. Now, we are finding a general solution. So, integral, this is the m1 is minus x square by y cube into dx. So, on integration with respect to x, treating y as a constant plus n1. So, what is the n1 here? So, what's the term we have to take which does not containing x terms? So, observe the first term clearly x included, so that don't consider this term as an n1. So, take only the second term is 1 by y. So, in this 1 by y, x is not there, so that you have to take 1 by y is an n1. 1 by y dy is equal to c. And now we have to integrate. So, in the first integration, minus 1 by y cube is a constant. Integration of x square is x cube by 3 plus integration of 1 by y is log y is equal to c. So, minus x cube by 3y cube plus log y is equal to c is the required solution. So, this is the general solution of the given exact differential equation. So, what's the process we applied in the method 2? So, first, in the method 2, what's the method 2 is, first of all, you have to verify the given differential equation m dx plus n dy is equal to 0 or not, the given form. So, if m dx plus n dy is non-exact, so what is the non-exact condition? Dou m by dou y is not equal to dou n by dou x. So, after verifying this condition, again you have to verify the given differential equation m dx plus n dy is equal to 0 is a homogeneous differential equation or not. So, if it is the homogeneous differential equation, then you can find an integrating factor. 1 by mx plus ny is an integrating factor. So, after finding an integrating factor, multiply this integrating factor to the given differential equation. So, after multiplying, we will get this differential equation is an exact differential equation. After getting exact differential equation, so find a general solution. So, what's the general solution is integral m1 dx. So, on m1 we are keeping y as a constant plus n1 dy. So, on n1 we are taking the terms free from x is equal to c. Right. Today in this session, we discussed about the method 2 of finding an integrating factor, and we did the one problem on finding an integrating factor. In the next session, we will discuss about the method 3 of finding an integrating factor. Thank you.